What is the toughest question you could ask a large language model? I bet you have been thinking about this. Well, me too. But I discovered that it's actually a more interesting question to ask. How does the large language model look that can solve such a difficult question? Right now, there are two scaling laws that determine the performance of large language models. The first one says that a model gets predictably better if you increase the amount of data parameters and compute exponentially. But then, with the arrival of the reasoning models, such as O1, there came a second scaling law that says that your model also gets predictably better if you increase the amount of test time compute exponentially. This is the amount of compute that models can allocate to think before they answer. Both of these scaling laws are already saturated because the resources of the Earth cannot maintain much larger language models than the ones we have now. And there's no one in this room that wants to wait a month to get an answer from a large language model. So we need to know how to make large language models better without just making them bigger and bigger. And to do that, we need to get insight into why some models perform better than others. So me and my colleagues analyzed the relationship between reasoning and performance in OpenAI reasoning models, and we found that there's actually a third scaling law that determines performance in large language models that says that more reinforcement learning leads to more effective reasoning in large language models. And this scaling law actually shows more potential than the last two because it does not require larger base models or longer and longer reasoning. To understand why we claim we found a third scaling law, you need to know three things. The first thing is related to the methodology of our approach. And the second and third thing are two main results of our paper. Over the last year, OpenAI has released a series of reasoning models that all have the same base model, the O series. O1 and O3 are two consecutive models in this series. They don't differ in the size of the base model or the amount of data they're pre-trained on, but they differ in the amount of reinforcement learning in the post-training phase. So O1 and O3 actually make perfect test cases to investigate the effect of reinforcement learning on the abilities of large language models. A first thing we did was compare the performance of O1 and O3 on Olympiad-level math questions. And as you can see on the graph, O3 consistently outperforms O1. But this result does not really tell us why. But luckily, we did not only look at performance, we also looked at the use of reasoning tokens. So this figure shows you the performance of O1 and O3 across the reasoning token distribution. The green versus red bars show you the ratio between correctly and incorrectly answered math questions. So it's immediately obvious that O3 gives more right answers for the same level of reasoning tokens than O1. This is also encoded in the error rate. For a fixed amount of tokens, O3 has a lower error rate than O1. This results only gives you a static view, right? But as reasoning is a process, let's look at how performance evolves when models keep thinking longer and longer. Because the reasoning token distributions of O1 and O3 are almost identical, we can compare the slope of the performance versus reasoning curves of O1 and O3. We use the regression analysis that accounts for the difficulty of the questions to quantify the effect of an increased use of reasoning tokens on performance. And we found that O1 loses 30% in accuracy with 10,000 tokens, while O3 only uses 19% in accuracy. So as reasoning increases, O3 has a slower performance decay than O1. If we now combine these two main results, we can conclude that more reinforcement learning leads to more effective reasoning in large language models. Because, as you remember, the only difference between O1 and O3 was the amount of reinforcement learning. So there's actually a third scaling law, which is unexplored, that shows huge potential in the sense that it does not require a bigger model or longer reasoning chains. So where do the abilities of large language models scale to? We don't know. But how we will scale them, it's with the third scaling law.